We're always trying to predict the future, be it by analyzing the motion of animals to predict their future positions, figuring out coming eclipses, or developing a weather forecast. Humanity has always been interested in knowing what comes next. But how can science predict the future? The answer is measurements, calculus, and calculations. Measurements give us information about the present. They're what we use to describe an initial state. Differential equations are tools from calculus that use rates of change to describe how each measured variable evolves over time. We can couple these with known laws of physics to describe how real-life systems evolve. Then we can do calculations to find the evolution of our initial state. And evolutions can be plotted in a phase space, where each point represents a different state of a system. But because of chaos, this process doesn't work well when predicting the weather. Slightly different initial states will eventually evolve into extremely different forecasts. Because when predicting chaotic systems like these, tiny differences between a model and reality, like the presence of a butterfly, will grow exponentially and become large errors, like the presence of a tornado. This is known as the butterfly effect, or sensitive dependence on initial conditions. So for chaotic systems, the future can only be predicted before measurement and modeling errors grow too large, which happens in the time frame known as predictability horizon, and they resist change. Increasing information exponentially only stretches them linearly. That's why weather forecasts today are just slightly longer than 70 years ago. Chaos is why the future cannot be extensively predicted, but it's not an obstacle. Understanding it made us see order where we only saw randomness. We see it in the form of attractors, phase-space structures that concentrate the evolutions of a system. So if you ever think life is a disordered and chaotic mess, remember that even in chaos, there's order and beauty.